Welcome to the second part of our two-part webinar on product quality and consistency. In part one, we covered how to optimize your biological plan to produce consistent volumes and sizes of fish for your customers. For part two, we'll be focused on purging and other procedures that can ensure that your fish taste great, have a palatable texture, and haul well, whether you're going to a food fish market or into a pond. My name is Amy Schambach, and I will be your moderator. Today's webinar is sponsored by Illinois-Indiana Sea Grant, the North Central Regional Aquaculture Center, also known as NCRAC, NOAA, Illinois Extension, and Purdue University's Department of Forestry and Natural Resources. During the presentations, we do ask that you keep your cameras off and your microphones muted unless you're the presenter or the speaker, and we'll have an opportunity to unmute ourselves and ask questions at the end. With that said, I would like to introduce you to Dr. John Davidson, who will be giving the first talk on optimizing depuration procedures for optimal taste and product quality. John, the screen's yours. Will you please start by sharing a little bit about your background?
Sure. Thank you, Amy, and thank you for the invitation to speak today. I am a research scientist at the Freshwater Institute in Shepherdstown, West Virginia. I've actually been working here for quite some time. It's been 23 years now. I started right out of undergrad, and which was at Shepherd University. Along the way, I got my master's in fisheries science from West Virginia University, and recently completed my PhD through the University of Bergen. So it's been a great ride, and quite enjoy my role at the Freshwater Institute. Just a little bit of background about who we are. We have been focused for many years on developing sustainable aquaculture systems and practices in support of a growing domestic aquaculture industry in the United States. So obviously we're raising fish and we're understanding technology. We have engineers that have created some nice systems that we use at our facility and can recommend to folks in the field. But we also answer very specific questions through applied research. And one of those areas that we have done a lot of work in is off-flavor remediation. So obviously that ties into my talk today. And I'll be discussing a specific procedure that we have developed over 10 years of research that we recommend for use by RAS facilities or facilities that use water reuse. I'd like to recognize our research team. These folks do a lot of work in the background. They're not always giving presentations. Travis May actually gave a presentation in this series last week, I believe. But this is essentially our fish production team, water chemistry crew, and our director of research, Dr. Chris Good. And then in terms of funding sources for this particular work, there have been many. NOAA Sea Grant funded a few studies that I'll talk about. Recently, we received some funding through a USDA NEFA SBIR grant. Ohio State University is not a funder, of course, but we're an important partner for a taste panel. And then our primary funder over more than 25 or maybe even 30 years now has been the USDA's Agricultural Research Service. And we have developed consistently 5-year plans under their umbrella to carry out research in support of the domestic aquaculture industry. So I just quickly wanted to touch on the reason that we are funded by the government, especially for that length of time. And really, if I have to talk about just one topic and one reason, it really boils down to the seafood deficit that we have in the United States. So we import almost all the seafood that we consume in this country. And you can see that this is actually in billions of dollars. So these are the dark blue is the import value. We're only exporting a small amount of seafood, and it results in this tremendous trade deficit. At the Freshwater Institute, we're focused a lot on salmonid production. And when it comes to Atlantic salmon, this trade deficit also applies. So if you go to a restaurant or a grocery store and you purchase Atlantic salmon, most of that is coming from a different country, Chile or Norway or other European countries mainly. But we have shown at the Freshwater Institute that we don't need to import seafood. We can raise it here in the United States. and we can actually raise market size Atlantic salmon far away from the ocean using fresh water and using recirculating aquaculture systems. So just a little bit of background before I get into the off flavor side of things. The Freshwater Institute is a program of the Conservation Fund. They're our parent company, and they are largely focused on land conservation throughout the 50 states. We cover a nice little niche under their umbrella in that we're focused on water conservation. And all their projects typically have some economic component. So we're doing water conservation wisely, and we're also adding an economic component for us, which is aquaculture. This is a beautiful shot of our campus in rural Shepherdstown, West Virginia. This is our main research building that houses a large demonstration tank and some smaller juvenile production tanks. Our offices are here. We have some greenhouses available to us, which are mainly for waste production. We also have or waste treatment. We also have replicated RAS in this white greenhouse bay, more research facilities and fish tanks in this relatively new building. And we could do construction projects in our barn area here. So it's a beautiful place to work, but we wouldn't be located here if we didn't have access to a nice clean water that we can raise fish with. So this is the 1800s, early 1800s spring house that we have on site. Provides nice clean water for us to use in our systems. We actually pipe the water from the spring house into a pump house, and then we distribute that clean water to all of our fish research buildings. In terms of this particular presentation, I should also note that our water is essentially free of all flavor, which is very important when it comes to fish production with RAS. So just a quick snapshot of what you might see inside of our facilities if you were to tour the Freshwater Institute. So this bottom picture is a view of our wet lab facility, and the showcase in this facility is our large RAS tank. This is an 8-foot deep tank by 30 feet across RAS that holds about 40,000 gallons of water. When we built this, it was a large tank. These days, when we consider commercial RAS for salmon, the tanks that we're hearing about are actually 10 times larger than this already large tank. What you see behind the systems are essentially unit processes that are reconditioning the water. So we have a drum filter, we pump through a fluidized sand biofilter, gas conditioning, we add oxygen and the water flows back into the tank. This is a large crowding device that we use to manage the fish when we go to harvest. And we have feeders located on each side of this large tank that, and a spreading wheel that will spread that feed out. In this direction, we have our juvenile production systems. And what you see here is actually in this area, it's our intermediate fish production where we're raising smolt size salmon. This is actually a picture of me many years ago where I had a lot more hair than I do now. But it's been a great run and a great job. This is a shot in our newer research facility. And for these projects, we like to have replicated tanks so that we can carry out scientifically relevant research. So on the fish side, and particularly when it pertains to salmonid production, we take the fish through the entire life stage. Life cycle. We begin with fertilized, disease-free eggs that we receive at our facility. You can see the little eyes here. And then shortly thereafter, these fish hatch out into the alvin stage where they have a yolk sac that they use for nutrition. They absorb the yolk sac and become small fish, at which time we begin feeding. And then over the next 22 to 24 months, we're able to grow these Atlantic salmon to market size at our facility. We've also raised other salmonids on site, rainbow trout or steelhead. We do a lot of work with. We've also raised Arctic char and coho salmon, brook trout, brown trout, and a few warm water species as well. We can make adjustments. We've raised walleye and yellow perch at our facility as well. So that's kind of the really quick background about what we do and what we have available to us at the Freshwater Institute. We're really good at raising fish and understanding water quality and fish biology. and we have engineers that have established the base RAS design that we use at our facility. But as I mentioned earlier, we're a very stakeholder-driven organization, so we're answering very specific questions to try to help farmers out. And one of the questions that comes up quite frequently is related to off flavor and how we can solve that. So we've put a lot of research into this area. I'll start with a little bit of background in case there's folks tuned in that may not be familiar. Most RAS facilities are challenged by off flavors, much like the pond industry has been. It's a little bit different. I think different types of bacteria are involved, but many of the same off flavor compounds are at play in these various types of production systems. So we're concerned about these two primary off flavor compounds, geosmin and 2-methyl-isobornyl, or MIB. And these are metabolites of very specific bacteria. Generally, these bacteria in RAS are persisting and growing in these thick biofilms that you can find throughout the system. I've highlighted a few places where we actually have worked with microbiologists that have identified off flavor producing bacteria at these locations, but really they can grow anywhere in these systems. And there's going to be places where you can't reach these biofilms to brush them away, such as inside of pipes or inside of a heat exchanger. This is a high surface area media that would be contained inside of a gas conditioning column. And this is kind of a translucent look at what you might see inside of a fluidized sand biofilter. So this general setup makes it very difficult to remediate off flavors. So we have to have other solutions in place, often beyond the RAS itself, to eliminate these earthy, musty flavors. So as I mentioned, it takes almost 2 years to grow a market-sized Atlantic salmon at our facility. And over that time, obviously there's extensive effort and investment that goes along with that: energy, feed, oxygen, labor, and really all the hard work that the personnel are doing to get these fish to a place where they can become a food product. And these are some nice orange fillets that we produced at the Freshwater Institute. We did a little bit of a marketing campaign. However, you could certainly have these very beautiful fillets that are nice in appearance, but taste terrible if you don't go through the right steps. So we are very keen on making sure that RAS farmers know about specific finishing steps that they should follow at the end of this production cycle for the fish, to ensure that these fillets are all flavor free and that they're high quality premium products and just don't look good but taste good. So I'll walk you through the general procedure that we use, and it's a process that we call depuration. It's kind of the scientific word. We also refer to it as purging. And essentially it involves moving the fish out of the primary RAS into a separate clean water system. So what you see in the pictures here are our fish production staff that are getting that extra system ready. They're power washing, they're cleaning. We have very hard water at our facility that produces a lot of calcium. So this is Curtis power washing some of that calcium and biofilm off the tank walls, and Anna doing some cleaning. And once we get to that point, we refill the system with clean spring water. And this is Curtis using safety procedures to add hydrogen peroxide to the system so that we create a concentration of about 200 to 250 milligrams per liter. We recycle that water in a closed loop through the system. And essentially by doing that, we're able to hit all the internal surface of pipes and all of the parts of the system that we wouldn't be able to reach necessarily, to make sure that we don't have off flavor producing bacteria in these systems. So the next step, once we have that system ready, is that our fish production team will crowd the fish in our large grow out system. So they've crowded up these market-sized Atlantic salmon, and they're gently moving these fish into a side box and then down through a pipe. And the fish essentially just falls into the water in a nearby tank, which is close enough that we can use this large pipe. So that's the process to get the fish out of the tank. And then we have a very specific process within that tank. I mentioned earlier that it's extremely important that we have water available to us that is low in off flavor. And I would recommend that to farmers that are potentially looking for sites for RAS facilities. So once the fish are in this system, we are exchanging a lot more water through this partial reuse system compared to what we would do in this RAS. So it's a much higher water flushing rate that we use. The fish are eliminating all flavor across the concentration gradient during that process. And we're also keeping the fish off feed across a 6-day purge period that we have found works at our facility. But that duration of the purge cycle is very specific to from facility to facility. With this process, we've never had any complaints about off flavor from chefs that we've sent our fish to and tested with, or distributors. And obviously we've tasted a few fish over the years, and nobody's ever tasted off flavor after that purging period. So this is what the purge system looks like. This is an 18 cubic meter tank in gallons. I believe it's about a 4,700 gallon tank. So we're stocking some of the fish from our grow out system in different intervals into this tank, usually at about 100 kilograms per cubic meter. So close to 1 pound per gallon that we can stock in this tank. It's very simple partial reuse design. So we pump from the side box through a gas conditioning column to take out some carbon dioxide. We reoxygenate and the water comes back into the tank. This is a partial reuse system, not a true RAS. So water is constantly leaving this system through the bottom drain, which I'm circling. It's about 10 to 15% of the flow leaves from this bottom drain. And we replace that with the fresh, clean spring water that I showed that comes from our spring house. It's exchanging pretty quickly. So we have about 6 to 7 turnovers per day for a 3-hour system hydraulic retention time. And again, I mentioned this 6-day purge period with the fish being all feed. And then after that, we will harvest and slaughter those fish. And often we'll try to send those fish out as food product, typically through donation. We just donated some fish to the West Virginia food banks. So this is the process that we have essentially established over many years. We didn't come to this process by chance or guess at it. We carried out applied research over many different projects and learned and fine-tuned this process across that time period. So this was one of the original studies that we carried out that was published in 2012 by Gary Burr and team at the USDA ARS Center in Franklin, Maine. And in a nutshell, what they found during the study is that fish need to be removed from the primary RAS. It really isn't recommended to try to purge those fish in the main RAS system, but it's better to move them to a separate clean water system. The other thing that stood out during this particular project is I talked about 6 days of depuration at the Freshwater Institute, but they found that to get to the lowest residual geosmin and MIB, it took 10 to 15 days. And that's a relatively long time for the fish to be all feed. And what they also found with these longer duration purging is that they had some fish weight loss, which would affect profit margin. They had some reduced fillet color and lower lipid levels that would certainly contain the heart healthy omega-3 fatty acids that you're looking for with Atlantic salmon fillets. So in realizing, some of these attributes from this study, we really wanted to take a stand and try to reduce the duration of purging. And we have done that to get down to the 6 days at the Freshwater Institute. But we did it through applied research and trying to figure out what steps we could take to reduce the duration. So the next study that we carried out on site at the Freshwater Institute was looking at 2 specific variables that potentially would help in that regard. Disinfecting our systems with hydrogen peroxide, which I've mentioned, and then also excluding aeration media like you see here that has this high surface area. So this could certainly be a vector for all flavor producing bacteria and the biofilms that they grow in these kind of systems. We organized this great team of scientists, some from Canada, some from USDA ARS, to help us with a study like this. And what we found is that systems that we disinfected, we pre-disinfected these purge systems with peroxide, and we excluded this water aeration media. Typically, this would be inside of a gas conditioning column like you see here. But in purge systems, you really don't need this because the fish are often taken off feed and they're not creating a lot of CO2. So we excluded this media, and with that combination, we found that we slightly improved our purging. And you can see that this kind of dictates that 6 days for us. Right here, we had our lowest residual off flavor levels at 6 days in Atlantic salmon, and we're looking at geosmin specifically right here. So the next research project that we carried out was funded by NOAA Sea Grant. And again, really looking into how we can fine tune and make better this depuration process. For these particular studies, we looked at trying to pin down how much water we need to exchange through our depuration systems, looking specifically at hydraulic retention time, which is how much water you need to exchange through a system to completely replace the volume of that system. And these are the hydraulic retention times in hours that we tested. Again, co-authors, I don't know if I mentioned it, Dr. Steve Sommerfeld, he was our research director for many years. He now works at Superior Fresh in Wisconsin, which is a Atlantic salmon aquaponics facility. A second study we carried out under this NOAA umbrella was looking at factors that could influence Atlantic salmon metabolism in purge systems. So potentially using dissolved oxygen and fish swimming speed to cause these fish to eliminate or excrete more off flavor in that process. So for the first study, when we looked at water flushing rate and hydraulic retention time, this is kind of a scientist's dream to see this kind of data, this nice stair-step data with standard error bars that are separated between treatments. So we quickly found that the hydraulic retention time of these systems strongly influenced the rate of geosmin removal. So what we're looking at here is the residual geosmin that is being released by the fish in the water. And depending on how fast that water is passing through the system, it's carrying that released geosmin out of the tank and away from the fish. So this is the same study, but the geosmin concentrations in the fish flesh. So this is the full depuration curve, and we actually boosted the geosmin levels in the fish early in the study. And you can see this exponential decay that happens after you put those fish in clean water. So what I did is I zoomed in on the fish data for day 3, 6, and 10, which you see here, just looking at it in a different perspective. And we also get this stair-step data set. So the fish, the geosmin in the fish flesh is following very closely to the trend that we see in the water for these fish. And we can very easily see that the 2.4-hour hydraulic retention time, which we're exchanging the most water, is resulting in fish that have the least geosmin in their flesh. So something that's interesting when we look at this kind of plot is we really don't know for sure when these fish are truly purged or on flavor. So we don't have an exact number to match with the taste threshold that people have. We've always purged fish below this 100 nanograms per kilogram mark. So you can see that we've achieved that with the 6-day purge cycle, which again matches with what we've established. However, it could be that all these treatments have purged fish. It may just take a little bit longer if you're exchanging less water. So all the fish and all the treatments were purged by the time we reached 10 days. So there's some flexibility here depending on how much water a farmer has available to them at a farm. So with this question of off-flavor taste threshold, we recently carried out a taste panel with Ohio State University. So we had recently done a study where we had some salmon that had different geosmin concentrations in their flesh. And when we carry out a study like this, we'll send part of the fillet out to an analyzing lab, and we'll save the other half of the fillet at our facility in freezer storage. So in this case, we got back the data. We knew that we could match that data to a fillet that we still had. And we organized fillets with different geosmin concentrations from less than 100 nanograms per kilogram to more than 400. And we sent those fillets to Ohio State University because they have a very specific sensory analysis lab and scientists that work in that lab at Ohio State. And they organized this difference, what they called a difference tetrad test. in which the panelists are asked to discriminate between fillets. In this case, the panelists were untrained, but they were salmon. They were self-identified as salmon consumers, and they're essentially given fillets from each of these groups and asked to try to group the fillets based off of similarities. So they'll get little cups of salmon fillets with control versus low, control versus moderate, and control versus high, and try to group these fillets based on what they perceive as being similar. So there's a lot to talk about. I have a whole presentation just on this, but quickly into the data. And essentially what they found is that when they looked at the low versus the control versus low, they didn't see a significant difference, which they would have to reach a number of correct responses to get to this green line. So no difference control versus low, no difference control versus moderate, which was around 300 nanograms per kilogram. But when we get to this control versus high, which is a little greater than 400 nanograms per kilogram, the number of correct responses increases. So there are enough participants that are correctly grouping these fillets and truly identifying this difference that we think that consumers can taste slightly greater than 400 nanograms per kilogram of geosmin and Atlantic salmon fillets. Now, as the test goes, the panelists aren't specifically saying that they're tasting or not geosmin. They're just identifying this difference. But from the background, as scientists, we know that this is the key difference that we're looking at between these fillets. So I had mentioned a study looking at swimming speed and dissolved oxygen, and I won't spend too much time. Often in science, you don't get the nice, clean data and differences like we did in the first study. In this particular study, we didn't find any differences in the swimming speeds that we tested or the dissolved oxygen levels that we tested. And there is some practicality to some of this. So you really, as a farmer, wouldn't want to challenge these fish with very low oxygen. So there was obviously a limit. You might go down to 80% with Atlantic salmon, but you wouldn't want to risk your population at this stage of the game. And then in terms of swimming speed, we're talking about fish that are actually more than 2 feet long. So in order to get a much greater swimming speed as it is measured by body length per second, you would have to pump a lot of extra water, which would be even more energy resources involved in that process. So we don't think, in a nutshell, we don't think that swimming speed or oxygen really will make much of a difference in the elimination rate in purge systems. So I'm getting near the end here, and I wanted to wrap up with the fact that we have really been looking at this external process called depuration. We move the fish out of our RAS into a separate system. However, there are some drawbacks to that. So the depuration process takes a lot of water. It requires right now other systems, more energy. So while it works, it may not be the end all, and it may not be the most optimal process that we use, 5 or 10 years down the road. So very interestingly, at the Freshwater Institute, we're trying to research off flavor, but we really don't have a tremendous problem with off flavor. So in this particular study, we were actually trying to take measures to create off flavor in salmon in our primary RAS. We did things like we stopped brushing and cleaning to allow biofilms to grow. We added sand from another system. We increased water flushing and try to disrupt the system. But throughout this process, aside from this one data point, we had very low off flavor in these systems, less than 3 nanograms per liter of geosmin and MIB. And we took fish out of the system later, and they were already essentially on flavor. They had less than 100 nanograms per kilogram of geosmin and MIB in their flesh, and they were ready to be harvested. So this really is what every RAS facility would love to have. And at this point, the next step in our research process is to really try to understand what parameters and characteristics and conditions are imparting these low off flavor levels at the Freshwater Institute. One aspect that stands out to me is that these RAS have been operating for more than 1 year without shutdown. We potentially had an opportunity here to establish a very mature microbial population, potentially one that had other bacteria that were out competing or consuming all flavor producers. Here in this zone, we're operating with a really low water exchange rate, which also might be related. And in this zone, we obviously increase water flushing, and we're potentially bringing into the system more all flavor producing bacteria from our spring water supply. And then we have very unique water at the Freshwater Institute. We have very hard water with hardness and alkalinity near 300 milligrams per liter. And we have an engineering design that maintains very clean water. So next steps for us are really looking into some of these metrics and trying to flesh out why we have such low all flavor in our RAS at the Freshwater Institute. So just a few wrap up points. Depuration right now is the standard for RAS production of salmonids and likely other species that are raised with this technology. We strongly recommend that developing companies use depuration at their facility to ensure that their product is on flavor before it goes out into the marketplace. We continue to research the depuration process and to try to find ways to shave days off of it and to especially reduce water use where we can, because it does require a good bit of water. I mentioned that we have very low all flavor levels in terms of the concentrations of geosmin and MIB in our water supply. That does not always mean you don't have all flavor producing bacteria. We can clearly create all flavor in our systems, but to purge fish, you definitely need to have a water supply with low all flavor. So that's something to keep in mind as facilities are expanding or trying to find sites. And then I mentioned that what we call the Holy Grail would be to figure out strategies like we currently have at the Freshwater Institute, but to fully understand conditions that impart low all flavor in RAS, I think it is an important next step. So just a few disclaimers. Recognition of our funding bodies, the USDA sources and NOAA again. I always like to highlight, many of our team members at the Freshwater Institute, our fish production folks, our water chemistry team, which is Megan and Natalie, operations team, JC and Shannon. Kata does a lot of our engineering, drawings, and support. And wanted to point out that one of the things I love about my job is I can give presentations like this, and we can make our research publicly available to everybody. So please, if you have any questions that we don't get to cover later, please email me, or you can also go to our website and find all of our peer-reviewed publications and trade press articles on our website. So that wraps it up for me. And again, thank you, Amy, for the invite, and I look forward to discussion a little later.
Thank you, John. We're going to go ahead and hold our questions for the sake of time and jump straight into our next talk, which is preparation of transportation of live warm water fish. That's going to be presented by Forrest Wynne. Forrest, if you want to go ahead and share your presentation and give us a little background about yourself.
Okay, can you hear me first of all?
I can. Your presentation is not in presentation. Oh, there it is.
Good enough?
Yep, I'm going to mute myself. It's all yours.
Okay, great. Yeah, name is Forrest Wynne. I work with Kentucky State University, which is part of the 1890s land grant institution, chain of institutions here in the southern United States. I've been working with basically various pond systems, all the way from fairly intensive aquaculture pond systems all the way down to private recreational ponds, fee fishing operations, even have some involvement in water gardens, although I will profess not to know much about it. But I've been at this for decades now, and some of what I'll show you here is just what we have come across in terms of basically harvesting, handling, and hauling warm water fish species. John did a good job presenting the cold water side of things, so I will stick mostly to the warm water fish species and just show you in a very, very short period of time just some of the highlights of considerations that we want to have bringing fish to market, both for food fish, that is, to live fish markets, and also fish for stocking ponds and lakes. So hopefully this will all work. Some of the fish species we deal with here, particularly in the South and the Midwest, are species of fish for pond stocking, and this primarily includes the largemouth bass, bluegill, red ear sunfish, and channel catfish. These fish have been found to work the best in our small human-made ponds, lakes. They really provide the best fishing, and particularly the largemouth bass and the bluegill can constitute their own predator-prey dynamic, where fish really don't have to be externally fed. Pretty much the bluegill can feed the bass, and the bass will feed on the bluegill and keep down the numbers of bluegill. And if stocked in the right numbers, these fish will create a self-sustaining fish population. And the two fish you see on the bottom, the red ear sunfish and the channel catfish, can be stocked in as supplemental species. They don't really play a role in the predator-prey relationship, but these are quite popular in the ponds throughout the South and in the Midwest, these types of stocking arrangements. Most of these states will have some stocking practices that they follow. Other species, the big three, particularly grown here in the South, are the goldfish, the golden shiner on the bottom, and not a great picture, but a fathead minnow or rosy red minnow on the left. These are the three large selling bait fish in the South. Obviously, these fish have to be transported. All these fish have to be transported in a situation where they survive and remain, are stocked into the pond in a disease-free and manner in which they're not damaged. So we'll talk a little bit about transport here, just showing you some of the species that may be considered for market, or fish that are in fact marketed already. Tilapia, John mentioned these, sold here only as a food fish in our state in Kentucky, but in other places may be sold for aquatic plant and algae control, but primarily a food fish to my knowledge. These can be both grown in southern ponds and indoor RAS systems throughout the country. Quite a popular food fish. Very hardy fish, makes it easy to grow. Easier to grow than other species, and tolerant of some poor water quality, relatively fast growing fish. This is a tropical fish or subtropical fish, so that needs to be mentioned. Water temperatures much below 60 degrees are going to kill your tilapia. Carp, all kinds of carp sold for ornamental species. Down in the bottom right is a grass carp, probably the most prized of the food of the carp species as a food fish. Also, in many states sold as a triploid and some as a diploid for aquatic vegetation control. They control pretty much easily digested branched algae and soft stem vascular plants for aquatic plant control, ponds and lakes. So they've been used for that over a number of years. And of course, up on the upper left, we have koi, ornamental fish, can be quite valuable and highly sought after for various ornamental pond situations. Bottom left, your standard, what I would call European carp. And these are found, whether we like it or not, throughout many of our reservoirs and ponds, stocked many years ago, and in some cases considered a nuisance and an unwanted species, particularly in the Midwest and in the South. Hybrid striped bass, typical fish that is grown is the hybrid consists of the male striped bass and the offspring, or in the eggs of the female white bass, grown together as a hybrid. This is probably the most popular type of hybrid, and is a good food fish and a sport fish as well. Largemouth bass, again grown as a food fish and sold in many states, particularly to ethnic markets. It's sold live in live fish markets, in addition to being sold as a predator species in pond and lakes for sport fishing. So largemouth bass really has two markets, and both are quite lucrative in terms of price per pound. Fish going for good size largemouth bass going for a number of dollars a piece in either market. And the bluegill, which is also unfortunately rather slow growing, but a very good eating fish, also has some food fish market potential as well. So that's one we hope to get better growth out of over the years. It's hard to beat a bluegill in terms of a good eating fish. It's just difficult to get them up to a food size, probably in the realm of 6 inches, something like that. Maybe 3 to the pound, somewhere in that range would be considered a food size bluegill. Catfish, I probably work with more catfish than anything, given my location, primarily channel catfish, although there are hybrid catfish now make up about half the southern catfish market. Hybrid is a hybrid of the blue catfish and the channel catfish. So catfish, of course, is quite popular in the various southern states and in the Midwest as well, both for as a food fish and also for recreational stocking. So what do? We have these species of fish. One of the biggest points that we need to make is don't feed the fish before transport if you can help it. We understand you might get into ponds and situations where fish in an emergency situation have to be transported and not taken off a feed a few days before harvest. But really and truly, warm temperatures, we'd like to have them off the feed 2 or 3 days. This is water temperatures above 65 degrees. And colder temperatures, it's even longer. Digestion takes longer. Fish are obviously cold-blooded animals. Digestion takes longer. So in those situations below 65 degrees, we'd like to have them off feed 4 to 5 days at colder water temperatures. And again, I'm talking about warm water fish. This improves the quality of the water during transport. The fish are not defecating and this sort of thing and fouling the water. Plus, it also reduces the stress. Little energy is used in digestion by these fish, and they can better withstand the problems associated with poor environmental conditions, water quality conditions in the hauling tanks, and also handling stress, the energy and the wear and tear it takes to get them into the tanks, and then of course to get them out and stocked into the receiving body of water or tank or just wherever it is they're going. Using the proper type of netting and harvest equipment is critical. For catfish and carp, we use polyethylene knotted mesh, and this will keep fin spines from getting stuck in the net. It's actually less stressful to the fish to use these harder, more resistant types of knotted mesh. These are similar to what you would find in the oceanic trawls from commercial fisheries. But most of our fish species need a knotless net, things such as bluegill, largemouth bass. You don't want to disturb the scales, the slime layers on the fish. So you want to use a soft, what we call a delta, I call a delta style mesh, a knotless netted type of material that will not abrade the fish. So again, using the right nets for the right jobs, for the right harvesting species is really where you want to be with this. Obvious things, keeping the fish in the water as long as possible. And when we're transporting fish, we have to know right before the fish go in the tank that actually fewer pounds of small fish can be hauled per gallon of fish than larger fish. So keep these things in mind. We want to do this preferably when water temperatures are cool, low light levels, just depending on the species of the fish. There's a lot to be known about transporting fish and harvesting them, and much of it is as much of an art as it is a science. So there's some things that have been found out over time, unfortunately, in some cases, the hard way. Water quality needs, and one of the things I find with many of my growers, I'm on my way to see a catfish grower right after this talk that's losing some fish. And one of the things we find is that folks don't pay enough attention to water quality. And it's really critical when you've got fish crowded up in these small tanks, bringing them to a live market to maintain good water quality, at least to start out with good water quality. Sometimes that water in the tanks can be quite degraded by the time you get to the market, particularly if the fish are crowded up, if the weather and the water temperatures are warm, or if the fish have to be in the tanks for many hours on end without a water exchange. And we'll talk a little bit about that. But ideally, you'd like to have for warm water fish dissolved oxygen levels up above 5 milligrams per liter at all times. I always recommend the use of cool water, probably in the 50 to 60 degree range. That's what our groundwater comes out at, somewhere around 60 degrees, except for tropical species such as things like tilapia, freshwater prawns. Obviously, that's not going to work. But for most of our temperate species of fish, keeping the water cool in insulated tanks is the way to go in terms of hauling the fish in a stress-free manner. Other factors, total alkalinity, hardness. Total alkalinity is the buffering capacity of the water. Hardness is calcium and magnesium content for the most part, at least with regard to fish water quality. These are the things we're interested in. You'd really like to have these parameters up around 100 milligrams per liter, somewhere in that range. pH maybe slightly alkaline, 7 to 7.5. Unionized ammonia, or the toxic form of ammonia, and carbon dioxide will build up over time, and you will have to or want to consider at least a partial exchange or maybe even a full exchange of water on long hauls, maybe even somewhere around the 8-12 hour mark, just depending on what your loading densities are. But it's critical to get these fish into good condition to the markets. Unionized ammonia will burn the gills of the fish, the gill filaments, and obviously low dissolved oxygen. You can arrive with either sick fish or very compromised fish that may not survive. Our fish, we mostly stock fish out into ponds. It's really in your interest to get these animals to the receiving body of water so that they can take a hook or that they survive well in market live tanks. Otherwise, fish haulers, farmers themselves often have to make up for losses of fish in transport or fish that die shortly after fish are transported to market within a couple, 3 days. It's not uncommon, particularly during warm water situations where fish will get sick, and there'll be large mortality due to low oxygen stress or handling stress that occurred during the harvest and transport process. So buying a water quality test kit, a 10 parameter kit, similar to what Hawk sells or Lamont, I'm sure there are other companies out there, learning how to use it and testing your water where the fish go in and checking it along the way is really, really helpful. So I can't overemphasize testing your water quality, knowing what you're getting into while throughout the transport and harvest process. Water temperature, again, critical. If you can use groundwater, I would recommend you do so. Things to know about groundwater is that a lot of times it has dissolved minerals such as iron, for instance, and may have some hydrogen sulfide. Groundwater really often is deficient in dissolved oxygen. So you want to agitate this water going into the tanks, making sure that you force air into it. Otherwise, you can have oxygen issues right off the bat. So make sure if you use groundwater that you agitate it while it's going into the tanks. Make sure it's rich in oxygen by the time you subject fish to it. And if you can't use groundwater or spring water, some clean source of water, use the cleanest source. Use the cleanest source of surface water you can that has relatively low organic load, not heavy plankton blooms and this sort of thing, which can deteriorate quickly and compromise your water quality in the transport tanks. Again, cool water works best. These are insulated tanks. You don't want to do this for tropical fish, but for most of our temperate species that I've shown you before, this is the way you want to go. One of the things I find a lot is people travel without a functioning dissolved oxygen meter, which is really kind of surprising. You need a functioning dissolved oxygen meter to help you regulate oxygen feeds, and we'll show you some dissolved oxygen delivery systems here very briefly. But really, you want to keep that dissolved oxygen up 5, even higher, because it may be able to compensate for some of the stresses that the fish are undergoing while in transport. Total alkalinity, again, very critical, and hardness, at least 75, maybe 100 milligrams per liter. Keep the ionic content up in the water, and this will help the fish osmoregulate as they go through the stress of transport and handling, restocking. Sodium chloride with no additives, just plain old salt, can be added in varying degrees from half a pound up to 8 pounds per gallon, depending on the species of fish you're hauling. It really matters what species you're hauling. Shad are very difficult to haul successfully, whereas other fish such as tilapia and catfish handle pretty well. Earlier, rainbow trout was mentioned. They handle pretty well. It really depends on the species of fish you're hauling and also its life stage. Adult fish tend to be more resilient to water quality stresses and handling stresses than perhaps juvenile members of that same species would be. So keep these in mind, keep these things in mind. In the same vein, loading rates, and these are very rough numbers, pounds of fish per gallon of hauling water. The fish are going to displace some hauling water, so you want to make sure you allow for that. But using minnows, you can see 0.7 to a pound per gallon of water. Catfish can be anywhere from 0.2 pounds per gallon on up to 6 pounds per gallon. And the 6 gallon per pound would probably be in the range of hauling fish to a processing plant. If you were hauling fish for a pay lake or a sport fish pond, you'd probably want to stay more in that 4 or 5 pounds per gallon range for hauling over good distances. But this gives you the range of a fingerling catfish, let's say, on up to an adult catfish somewhere around 6 pounds per gallon. And these fish would probably be in the 2 pound range of the adults. So that gives you some idea. Down below, you can see trout, 0.5 to 3 pounds per gallon. Again, these are basic guidelines, but just remember that the smaller the fish, the fewer pounds that you can stock per gallon of hauling water and have a good, healthy outcome. Size of the truck will determine the type of market. Remember, some of these urban markets, they're in downtown locations. The fish markets may be in rather tight neighborhoods with small streets. So you've got to be able to get your truck in and out of those places. Same with pond locations. The semi truck you see on the right here can haul about 20,000 pounds of fish, but obviously it's only going to be able to get into ponds and lakes that are fairly good sized that the truck can get in and out of. And trucks do go into ponds every now and then, and it's a pretty ugly business. So I recommend avoiding that at all costs for safety and other reasons. The truck you see on the left is better suited for small ponds, and it can get in and out. I always recommend in your pickup trucks and smaller trucks, 4-wheel drive. Again, you've got to be able to get in full and get out empty. And in spring, when a lot of the stocking occurs, oftentimes the ground is wet and muddy, and it can provide a challenge with stuck vehicles either coming or going. So you want to keep that in mind. Just capacity in gallons, some quick numbers right here, all the way down to what I would call a half-ton pickup down on the bottom, haul about 100 gallons of water on up, depending on the size and tonnage of your truck. Some things to know about tanks. Most are aluminum and fiberglass. The aluminum tanks tend to be a little more rugged. The bait minnow business tends to prefer fiberglass tanks just because they insulate better. They keep the water colder longer. Either way, the tank should be insulated for long hauls. I'm a big proponent of having the drains on one side of the truck so that you can offload without having to turn the truck around. It's a real nuisance to have to turn around a truck on pond levee system and come back just to offload your fish. And the same would be said if you were delivering to a store in an urban market. So have the right equipment for your particular market. Side chutes in the case for pond stocking, you'll need to get fish into transport tanks or something like this. Live fish markets, you'll have to work this out. Knife gates are essential in tanks to hold back the bulk of the water while you take these hatch covers off. So you want to make sure you have not only you have knife gates, but that they're in position to actually do the job. And most tanks now are fitted with overflow ports. I don't know about agitator holes. I think we've kind of gotten away from that in recent years, and hose ports to get oxygen lines into the tanks themselves. Types of aeration system: liquid oxygen, such as the truck is equipped with below. You see the door, the oxygen tank on the back end of the truck. Looks like it has fiberglass tanks as well on this one. There are other types of oxygen out there using basically regenerative blowers, compressed oxygen, these sorts of things. Generally, liquid oxygen is the best for long distance hauling, is the most efficient. Some of your older trucks that take fish short distances to processing plants aren't nearly as well equipped as would be trucks that haul fish long distances over the road. So again, the amount of fish you're hauling, the market, proximity of the source of the fish to the market is going to determine what sort of live hauling equipment you need: tanks, oxygenation systems, and these sorts of things. Just to show you a little bit, we have all this material in publication form. Most of this is anecdotal information, not real research based, just that has come down over the years. So here are some of the specs on these types of this equipment. The Southern Regional Aquaculture Center has publications out on this. I don't expect you all to consume this and get it right away, but this type of information is out here. Basically, we want to get you healthy fish to your market. And there are easier loads to haul than live fish, so there's plenty to know. Testing your water, having this testing equipment on board with you is critical, and making sure it works. Everybody who has interacted with dissolved oxygen meters know they can be finicky as best. So you want to make sure that this equipment is working for you and working properly before you start a trip. Just some other specifications on the amount of liters per minute of dissolved oxygen used, or gallons over time. These types of figures, again, are out there. I've helped put together some live hauling manuals. So just to know that this information is out there, and we can get it to you should you want it. Real useful thing in the bottom right, it's not the greatest picture, I apologize, that is a flow meter, making sure that there is in fact oxygen going into these tanks. It's a visual. Some have in cab, some at least you can get out every so often and check the meters, just a little ball meter in there, making sure that oxygen is in fact flowing into the tanks. Because it's a bad situation when it isn't. We've seen lots of dead loads of fish, and it's really something you want to avoid if you possibly can.
Forrest, we're at time, so if you can wrap soon, that would be great.
I am just about getting there. So again, some of the, to reiterate, probably a big one is using dechlorinated ice for temperature control. Bringing in dechlorinated ice to bring down water temperature is always a good practice. And compressed air systems, again, used for long hauls, for short haul systems, long haul being more liquid oxygen. And you also need to make sure you have air stones that are weighted to the bottom of the tank. Catfish have spines, so you will have to repair these and clean them periodically, or they will tear up the lines. And also, probably most importantly, tempering fish every 20 minutes for every 10-degree difference. Every unit of pH difference in the receiving body water from the hauling water will help your fish survive a lot. Take the time to do this, 20 minutes, 40 minutes, whatever it takes, and carry a submersible 12-volt pump that you can hook up to the truck just to pump receiving water into the tanks and allow the fish to acclimate before you stock them. That is what I have.
So we are at time. So if you do have to jump off, thank you for joining us. If you have a few minutes to stay on, I know John's available to answer a few questions, and Forrest, if you're available, we do have a couple questions.
Sure.
And we'll just jump into those. So John, Phil asks, can you speak to efforts to use ozone in the depuration process?
That's a great question. We have obviously have a long history of using ozone in our primary RAS. And we've actually found that low dose ozone in that scenario doesn't lessen all flavor in our RAS systems. Unfortunately, when we had the capability of using ozone with UV, we didn't actually test all flavor under those circumstances. So I have heard since that ozone with followed by UV, which allows you to put more ozone in the water, can reduce all flavor, but I have not been able to experience that for myself. In terms of using it in the depuration system, that's an interesting question, and we have not tried that. I think based on our experience with what works and doesn't work with ozone, that you'd be adding all the infrastructure and ability to dose ozone at the LHO potentially, but then based on our experience with low dose ozone, you'd probably have to have UV in that system as well. So you're adding these relatively expensive processes, I think, which starts to push against the economic viability of adding kind of a high-tech solution. That said, I think it would still be potentially interesting to study that, though.
Thank you. Forrest, Mike asks, do smaller fish between 380 and 900 grams reduce days needed to purge? And Mike is a largemouth bass farmer. Excuse me, he's a rainbow trout farmer.
I would think the purging rates would be pretty similar across the board, just because it's probably more of a function of water temperature. So obviously, the colder water the fish is living in, the longer time the food is going to need to move through the gut. So I would think that they're fairly consistent. That might be a good question for John, but that would be my take on
it. John, would you have something to add to that? And also, as a follow-up, what from purge can you use your purge water for makeup water in your RAS system?
Can you repeat the original question so I can address that one?
Do smaller fish, 680 to 900 grams, need reduced days for purging?
I don't know if I have an answer to that, from anything that we've gathered from science. I would think maybe they have a little bit higher metabolism and might be eliminating all flavor, but I don't know for sure. I would agree with Forrest's point about water temperature. And in fact, I think that was part of the difference we saw with the study that we carried out in Maine, where they obviously have much colder water in Maine, and we have warmer water in West Virginia, and therefore they had longer depuration periods. And then the second part, of the question?
The second part was, can you use the water from the purge tank as
Yes.
makeup water in your RAS system?
So I'm actually writing a paper on this right now. That is actually a general approach that's used out in the industry. Because you're using a lot of water in the purge system, it wouldn't make a lot of sense to just send that water to effluent. So many of the larger RAS farms will actually take that depuration system water and use it as supply water in the primary fish production systems around the facility. And the reason that they can do that is that the fish are generally all feed in a purge system. They're not producing a lot of waste that or dissolved waste that are in that purge effluent water. And so that water can then be used effectively as supply water. What I'm writing a paper on right now is that we're finding that even though the fish are all feed, there still is some waste in that water. So we've collected some data during a typical purge study, taking a deep look at the water quality that's in that effluent water from purge, so that if folks are designing systems, they understand what contribution that has, and then also to have an understanding of what it looks like for something like NPDES permits, that you still do have a little bit of nitrogen, phosphorus, and TSS that comes out of these systems.
So for a farmer that doesn't have the time and the research ability that freshwater has, and they want to start investigating purging on their farms for a species that doesn't have a lot of documented research on, how would you recommend that they start working through developing a purging protocol for their farm?
Yeah, it's a great question. So all flavor analysis is very expensive, first off. And we have always contracted out those analyses because at the cheapest lab you can find, it's going to cost $100 per sample, per flush sample. And fortunately, we have some funding that helps us in that regard. What we find that most places do is they have to taste fish. So they usually have to sacrifice a fish or two to understand if their procedures are working. You know, I would say that you have to use something similar to what we use in terms of the procedure, and then begin to develop your own procedure at your farm. So clearly you need to pass clean water, across these fish. And they should probably be all feed, as we talked about in both of the presentations. And really it boils down to what you have available at that given site. So some facilities have more or less water. They might not be able to achieve the retention time like we use at the Freshwater Institute. And if they don't have as much water, it just may take a little bit longer to purge those fish. So it is a very site-specific procedure that I think needs to be developed, site by site. That's the answer that I have right now, but certainly if anybody has any very specific questions that fall in that category, I could, certainly address emails or have an individual call with somebody to help them after the meeting.
Amy, I'll throw in too on the off flavor issue. I did not get into that because John discussed it at length in the cold water RAS systems, but in ponds, it's pretty standard procedure for, let's say, a catfish farmer, for instance, to flavor check his fish out in a pond ready for harvest a number of days before harvest, then again the day of, and then the processing plant will check a couple fish out of the truck before the fish are offloaded. And it has occurred to where entire loads of live catfish have been rejected and sent back to the pond because they were off flavor. So it's the flavor checking step in the processing business is critical. And unfortunately, since we have large ponds, we're not really able to purge or depurate fish the way John is mentioning. The fish often go back into the ponds, and it can take weeks, sometimes months for ponds to come back on flavor, just depending on water temperature. The colder the water temperature, generally speaking, the longer the offending odors, tastes linger in the fish.
I think you're muted, Amy.
Sorry, thank you. A follow-up to that was how subjective is taste testing? And from my experience, when I was doing yellow perch farming, we would take employees that had the most sensitive palates, and they would be the taste testers, because not everybody can taste off flavor as strongly as others. So you definitely want to find your tasters as somebody who's more sensitive, because those are the customers that are going to complain. Forrest, we do have one more question for you about feed. So before you transport your fish, how long would you want to have them off feed before you move them into the trucks?
Depending on water temperature, you know, I think I threw up a slide that said at about 65 degrees, you want to take them off 2 or 3 days before, and below 65, you would want to take them off before that, maybe 4 or 5 days. Depending on species too. I mean, it will, these are gross generalities, and I hate to speak in those terms, but it's a 20-minute talk on transporting fish. For each species, you would want to address this differently. And the market they're going to is going to have, and the size fish is going to have some bearing on that as well. If it's a pond stocking market where the fish are small and they're going into a pond that's void of fish, let's say, it's a different situation than when you're running larger fish, you know, 2-3 pound bass, for instance, or catfish, headed for the live food fish market. So it's really going to be somewhat market and fish size specific. You've got to take into all accounts what you're doing, and also duration of the trip. If you're going 20 minutes down the road, you can get away with a lot versus what 8 or 10 hours.
So that wraps up all of our questions. I would like to thank everybody for your time, and especially to Forrest and John for volunteering to be our guest speakers and for all the work that you do for farmers. You know, this would be the time that we would clap if we could do that in person. So just
thank you for having us.
Thank you.
We've enjoyed it.
Thank you very much for having me.
And that concludes today's webinar. There will be a recording uploaded to the YouTube channel for Illinois Indiana Sea Grant, and it will be tagged on the Aquaculture Marketing Series playlist. Please complete your evaluation survey. That helps us to develop programs in the future. And thank you for joining us. Have a nice day. And I will send Forrest and John's contact information so you can follow up with them directly if you have more questions. Thanks,
Thank you.
everyone.
Have a great day.